read it, and then after you read it, you give it to somebody else. And also there is in the room next to this one, at the end of the presentation, there are some refreshments. Sister Pat, where is that precisely? Yeah, yes, once you get out of the hall, it's on your right. Of course, we cannot start without asking a blessing. Let's bow our heads. God, we thank you for giving us another opportunity to be educated and to have this privilege of understanding the truth, not just about the creation, but the fact that you are the one who created everything, and you are in control, and you want to tell us all the details that are important for our faith. And also I want to pray for Stefano as he is going to speak, that bless him, give him the insights, the thoughts, the words that will touch our hearts. And we pray in Jesus' name, amen.
Good evening, everyone. I'd like to add my welcome to this evening. This is the second in our trilogy of three meetings. So last night, we dealt with the subject of do animals evolve? I introduced the subject of theory of whether evolution is a scientific theory. We looked at the three criteria for a scientific theory. We saw that neither evolution nor the creation position respect scientific theories, because we can't go back in time to study our origins. So we make deductions from what happened in the past by studying today, but we can't know for sure exactly what happened in the past. So I presented the concept of models to explain what we see around us and the importance of weighing up the models and the predictions that models have. And we saw that the predictions, so the transitional forms, which we can't find between all the forms of life, we saw the predictions about beneficial mutations and things going from the simple to the more complex. And we saw that really the scientific evidence in support of that just isn't there. And so I proposed that the alternative is that we are the result of a creation from a creator God. Tonight, we're going to look at the subject of the age of the earth. And when we study the processes happening in the world around us, do they tell us about the long ages or more recent ages, as well as dealing with the subject of dating and carbon-14 in particular? And then tomorrow night, we're looking a little bit more at our origins. How do we explain the diversity between all the people groups on this planet? And also we'll pass through the historical perspective of man's origins from a genetic perspective, but very simple level. So going into tonight's presentation then. Something's saying connecting here. I've got a Zoom thing rolling around. Sorry, a little technical hiccup. Let's see here. I need to rejoin? Yes. Sorry, I need to rejoin the Zoom to be able to connect. It's still trying to connect. I've put in the password and everything. Here we go. Okay. It should be sharing now. Yes, it's sharing. It's sharing. Maybe share a different part of the screen, maybe.
Okay, switch on the camera and let me see if it's pick up for me. Let me see.
Okay, that's or not the screen, maybe.
Yeah, that's what I did. Yeah, share it. Share. Yeah.
Maybe try the screen.
Okay, try the screen.
Still not doing it. Let me try again. And it's going through, trying to connect again now.
Is that your start, isn't it? Let's put it
Hmm.
Okay, so what I do, if I wonder why is it? Connect the cable and then take it from here.
Okay, so direct the cable to
Yeah,
this.
this
Okay.
one.
Okay. There. Okay. Wonderful. Isn't technology amazing and wonderful when it works? So let me put in projection mode. It is not going to projection mode though. Again, it's having problems connecting to the Zoom.
Okay.
Okay, you don't have a cable because my cable is. Yeah. It's connected again. So we'll get that. I'm not sharing. Okay, can I start? Okay, sorry about that. So today the presentation split up into two sections. The first one looks at the age of the Earth and what do the processes around us tell us about the age of the Earth. And the second half, can we trust the dating methods? So the picture on the screen is a picture of Burlingame Canyon in Walla Walla in Washington. And if I were to ask you the question, how many million years did it require to erode this canyon? You can see it's a pretty big canyon. We can see the different layers in the canyon walls. And quite often the answer I would get would be, I don't know, 500,000, 2 million, few million years. The reality is that this canyon eroded from a kind of a ditch like this in 6 days. So the question is how, why? Well, the history behind this is in 1926, they decided to deviate the water from some irrigation canals because they got blocked by branches, etc. And so they decided to deviate all the water into this kind of ditch so that they could clean out the drainage canal, the irrigation canals. But then suddenly it rained really heavily for 6 days. And that eroded this canyon which is 35 meters deep, 35 meters wide, and 450 meters long. It took away 150,000 cubic meters of earth and rocks removed in just those 6 days. So when we see a feature like this, do we know whether it was a little water over a long time or a lot of water over a very short time? And we've seen the devastating effects of a lot of water just in these days. Now in Spain, we're seeing the floods that are creating havoc and destruction because of the huge power of the water. Well, this is an example of a very rapid canyon formation, and there are other examples where certain circumstances, catastrophic circumstances, can create an effect that would seem to have taken millions of years to happen if one didn't know the history. Surtsey, again, is a very interesting study case. We can see here on the top right, the island of Surtsey. Why is it so interesting? Because in 1963, it did not exist. From a volcanic eruption, and we can see here in the bottom left picture, an airplane, and we can see that it's beginning to kind of rise up with a volcanic eruption. What is very interesting is that just a few months after volcanic eruption, we have wide sandy beaches on this island, gravel banks, cliffs, boulders, which have been worn by natural erosion, and gullies, again, created by water eroding away. And in 1965, flowers were growing in the ash. This was surprising for the scientists because first the flowers started to grow, and then soon after the ferns and other vegetation started to grow. Now, why was that so surprising? Because yesterday we talked about applying our assumptions to everything that we observe. And so the scientists applied their assumptions on the evolutionary development of life on this planet. And because they consider ferns and other vegetation to be more primitive and older in the evolutionary timescale than flowers, which are considered more advanced, more evolved plants, they expected to see the ferns first, and yet the flowers were there growing. And then between 1967 and 1970, moss and lichen started to grow. Again, completely reversed order for what the scientists were expecting. And quite interesting, a National Geographic article said, Only a few months sufficed for a landscape to be created, which was so varied and mature that it was almost beyond belief. So if they took some scientists, blindfolded them, took them onto the island, took the blindfold off and said, how old would you think that this island is? Their conclusion would be millions of years. And yet we know, because we saw it happen, that that island was born only in 1963. So as we go through life in school and we listen to the TV and we read books and so on, we hear about these processes that happen on Earth, geological processes, that we are told take millions of years to happen. And high pressure, high temperatures, for example, the formation of coal. Now, coal is considered to be between 10 million and 100 million years old. That's how long it takes to form coal, according to the evolutionary thinking. But Argonne National Laboratory, starting with some lignin or some wood, at 150 degrees, nothing exaggerated, using just water and acidified clay, produced high-grade coal in just weeks. Now, different grades of coal, depending on how far the process has gone in transforming the wood into coal. Opals, these beautiful stones. And I think there are some program or a program on TV that you can go, opal hunters. And then there's another one where they're looking for gold. And here they're looking for these opals, which we find in Australia. And there are these precious stones, and they have these beautiful colors. Well, Len Cram, in his backyard laboratory, in his garage, essentially, using common chemical substances, was able to recreate those same opals. What about diamonds? Diamonds, we're taught, take 100 million years at least to form. Man is producing them regularly now in factories all over the world. And it's only weeks, processes that take weeks, not millions, hundreds of millions of years. Anything from yellow diamonds, white diamonds, pink diamonds, they're not as big as some of the ones we find in nature, but these originally were being used just for industrial applications. Now they're actually being used for jewelry as well. And they're perfect. Some say, hey, but they're not real diamonds. They absolutely are real diamonds. They're made of exactly the same diamond structure from carbon atoms. Diamonds are essentially made of carbon structure. So under the right conditions, some of these processes can happen very quickly. Yeah, what about stalactites and stalagmites? We're told there as well that they take hundreds of thousands of years to form big stalagmites or stalactites. Well, in the picture here on the left-hand side, this is a picture taken inside a mine in Mount Isa, Queensland, Australia. We know that that mining tunnel was 50 years old when this picture was taken. And we can see these stalactites in comparison to the miners here in the bottom right corner. And if the miners are what, 1 meter 70, 1 meter 80, so like 6 feet tall, these stalactites are between 7 and 8 meters long in less than 50 years. How is that possible when we're taught that these things take hundreds of thousands of millions of years to produce things that big? All you need is water and the right mineral content dissolved in the water. What about stalagmites, which grow from the ground upwards? National Geographic in October 1953 had an article about a bat that had fallen onto a stalagmite in Carlsbad Caverns, New Mexico. What's so special? What's so interesting about a bat that's died and fallen on a stalagmite? What was interesting is that this bat had fallen and had been covered by the stalagmite, encased in stone, before it could decompose. How long does it take for a mammal to decompose? Days. Okay, maybe in the cave, it's a bit cooler than out in the sun. So maybe a couple of weeks, maybe. but it didn't even have a chance to decompose. And yet it was completely encased by this stalagmite. This is a picture of Dripping Well in Knaresborough, England. And we can see here that over the decades, people have hung items in this, in this well, in this dripping well. It's called Dripping Well. This, for example, is a hat from 1858, completely encased in flowstone. This is a teddy bear that within 1 year was completely hardened by these minerals. It's been petrified in less than a year. And why? How come? Because water with the right concentration of minerals dissolved in the water is able to produce this in a very short time. Here are a number of other objects which once upon a time a fossil was anything that was petrified. Now fossils are applied in terms of, as a descriptive term, only on once living organisms, plants, animals, which over time have been petrified or fossilized. But let's say these pseudo fossils, using thinking about the old use of the term. Here we have a bowler hat, completely petrified. On the top right, we have teepee fountain, where someone essentially stuck a pipe into the ground in 1903. Water gushed out from some underground source and created this hill of rock from the mineral deposits. We have here a spark plug encased in stone, and I actually found one on a beach, also a spark plug encased in stone. And you can see that the metal parts have been completely rusted away, but the ceramic part of the spark plug still there. Definitely not millions of years old. Here we have a water wheel, completely encased in stone in less than 60 years. And a particular type of barbed wire. From the type of barbed wire, it is known that it was only 20 years old. So again, under the right conditions, these processes can be very, very quick. But what do we say about the Earth, the tectonic plates, the continents as they're moving? We can measure them extremely accurately now using satellites and probes on the continents. So we can see that these continents are moving very, very slowly relatively to each other. So if we apply what is happening today with these plates, can we come up to any conclusions as to what happened in the past with these tectonic plates? So are they telling us that the Earth is old? So from the original Pangaea, the single continent, the various plates moved apart to create the continents that we know now. Can we apply the concept of uniformitarianism? What does this say? This concept says, if we observe something today, we can assume that the same thing happened yesterday and 1,000 years ago and 10,000 years ago and 1,000,000 years ago. Is that a valid assumption, is the question. Can we rely on that to assume how things went in the past? Well, if we believe that uniformitarianism is applicable, then we can say, well, yeah, it must have taken a very, very long time for those continents to move apart from the Pangaea in the positions where they are currently at now. And we're talking movements of, millimeters a year, or centimeters, only a few centimeters per year. But the question is it valid as an assumption that uniformitarianism applies? Talking about tectonic plate movement, Antonio Snyder was a creationist geographer. He proposed the idea because he'd seen the idea of the Pangaea and the shape of the continents and thought, this looks like a single continent that came apart. He proposed the idea of drifting continents in 1859, but he was way ahead of his time. No one else, none of the other geologists really accepted his thoughts. They said, nah, that's rubbish. Then in 1912, Alfred Wegener developed a similar concept. I'm going to have to turn this off. I'm going to turn my Zoom connection off. Is that right? Okay. Alfred Wegener then took Antonio Snyder's ideas and kind of improved them a little bit, from new understanding and proposed the theory of continental drift in 1912. But again, he was also way ahead of his time. He wasn't taken seriously by the other geologists. Then in the 1960s, a small group of geologists, actually at this stage, really the majority of the geologists in the world kind of came together and thought, well, actually, that Wegener guy and the Snyder guy, they actually weren't too wrong. And they essentially accepted their theories, perfected it a little bit more using the latest understanding. And so the theory of plate tectonics was born in the 1960s. And at this stage, everyone accepted the idea of these moving plates. Then in 1994, a small group of creationist geologists presented the theory of catastrophic plate tectonics. What was so different about their theory is that they proposed that the Pangaea separated during the biblical flood. Now that's recent. According to the creationist timing, that's about 4,500 years ago. How is it possible? If we're seeing that those plates move so slowly, it is not possible for them to have moved into their current positions in such a short time. But they proposed a different mechanism. It is called subduction, that under certain conditions, and they demonstrated this through a very accurate, probably the most accurate computer simulation using modeling techniques, demonstrated that with this subduction, where one plate moves on top of the other, you can get super fast movement of the tectonic plates. And we're talking about centimeters per second, not millimeters per year. And this has been recognized as probably the best simulation, and the physics works. So under certain conditions, even these kind of processes can happen extremely quickly. So the question is, can we accept and apply uniformitarianism? Maybe not, as demonstrated by this theory. So why is it that we think about millions of years when we think about dinosaurs? Well, yesterday I talked about our assumptions. We get influenced by our assumptions, which we pick up in the family that we grew up in the school where we get taught by the teachers, in the universities, in the books that we read, in the newspapers we read, in the programs that we watch on TV. So if we look at this fossil of a trilobite, for example, and we put it on our glasses tinted with evolution of millions of years, we will look at everything with these starting assumptions. It's normal, absolutely normal and logical. And so we will look at the entire world under these assumptions. And likewise, whoever grows up or comes to the conclusion of a recent creation, so this trilobite is a recent creation of God, then we will look at the whole world and interpret the whole world through these same glasses. What we need to understand is which model has more weight. So on to the second part of this evening's presentation. How is the Earth's age measured? Can we tell really how old the Earth is? And let's look at the dating game now. So let's assume when you came into this room that there was a table here in front, there was a tap that was dripping into a container for measuring liquids. You come in, you see the container, and there are 300 milliliters, 300 cc of fluid in the container when you come in. You observe it, you estimate, and you can see that the tap is dripping 50 milliliters per hour. So the question then is, how long has the tap been dripping? Anyone want to hazard a calculation here? 6 hours. Brilliant. You're obviously good at maths. Well done. I used to love maths as a kid. So what's the calculation that you did? 300 milliliters divided by 50 milliliters per hour equals 6 hours. Anyone disagree with that maths? Brilliant. Excellent. Unfortunately, however, the answer is wrong. yes, every dating method works in this way, but the answer is wrong. How do I know it's wrong? Well, let's say I set up the experiment. What if I tell you that the real answer is 1 hour? Can you explain why it wasn't 6 hours, why it was 1 hour? What could be one explanation? Okay, so what he's saying is, you assumed that the container was empty when you came in, originally, when the experiment started. So when you came in and you saw 300, you assumed it'd been dripping and filling from the beginning. Now, you're saying, knowing that the answer is 1 hour, you said, maybe when I started the experiment, there was already 250 in there. So it only took 1 hour to add an extra 50. That could be a good assumption. That could be an explanation. Any other explanations? Okay. Maybe before you came in, the tap was open more and it was dripping much faster. Okay. Do you know if it was dripping faster in the past? No. Why? You weren't there. Do you know how much fluid was in the container before you came in? No. Why? You weren't there. Now, that's the problem with science. We can't measure things in the past directly. And that's exactly how the scientific dating methods work. They start with certain assumptions as to what the starting conditions were before we started making our measurements. And this is a big limitation in our methods. We'll come back to that later. So in these dating methods, what is the starting point? Well, the starting point is this: the various geological layers. It's called the stratigraphic scale. So some geologists, some paleontologists got together with their evolutionary glasses on and said, can we do something to date the world, the layers? Because they observed that we see pretty much the same layers everywhere in the world, and we have pretty much the same fossils in those layers pretty much across the world. And so they proposed the idea that the layers at the bottom are the oldest, and as we get sedimentation, the more we go up in the layers, they are more and more recent. And they also, with the fossils, observed that with certain fossils in certain layers, we can use the fossils to date the rocks. And they're called index fossils. So certain fossils, if you find them, you can assume that the layer is a certain age. That's this assumption that they apply to the dating of these layers. But there is a problem. You may have come to this thinking already. So this is from the American Journal of Science. And it's a quote that says, the procession of life was never witnessed. Okay, the evolution of life. Remember, if you're not there, it's not real science. So the procession of life was never witnessed. It is inferred by observing what we see today. The rocks do date the fossils, but the fossils date the rocks more accurately. Stratigraphy cannot avoid this kind of reasoning. It is called circular reasoning. We'll come to that later. So let's say someone wants to build a new hotel or a car park. They start digging and they find something interesting. The work has to stop. They need to investigate. They call the experts, and they maybe find something interesting. They find a fossil. So they call the local paleontologist. The paleontologist looks at it and said, this is very interesting. Never seen one of these before. So the first question is, how old is this fossil? We need to date the fossil. The problem is we can't actually date the fossil directly. If we assume it's million years old and we've assumed the evolution thinking. So they look for index fossils. For example, this shell. if they find the shell, they can say, well, the shell, we know how old the shell is because it's an index fossil. And let's just say, I'm inventing a number now. Let's just say that this index fossil is 1.5 million years old. Thing is, we can't even date the shell. So what do? They look for igneous rocks, solidified lava. And look, there's an igneous rock in the same layer. So we have to assume then that that rock is the same age as the shell, the fossil shell, which is the same age as the fossil that we want to date. Now, we can date the rock. So they take the rock, send it to a dating laboratory, who perform certain measurements, certain tests. And what you'll notice when these tests are performed, and generally the general public doesn't have all the details, but what you will find is a very wide range of results. You know, and I'm again making up a hypothetical example. It can vary from 1.5 million years, 23,370,000, 136,000, 110,000. So when you make the measurements, you can get a very wide range of dates. But clearly, that rock isn't all of those ages. And so they have to apply some reasoning, some post-measurement reasoning based on what? Based on the assumed age of the rock from that index fossil, that shell, that the paleontologist said this shell is 1.5 million years old. Based on that, they will say, okay, well, these dates are too young or too old. These two are very close. So the age of the rock is the average of the accepted ages. So the average of 1.56 and 1.47. So the conclusion is the rock is 1.52 million years old. And the paleontologist comes and gets the result of the measurements from the laboratory and says, wow, brilliant. I knew this was this old. I knew it would be. So what's happened? Posterior reasoning had to be applied to arrive at the desired expected age for the rock. Now, it's the whole process is actually more complex than that. I'm simplifying it, obviously, for this evening's presentation, but the concept is there. Going back to this circular reasoning, if we have a fossil of a known age, remember the quote that I read earlier, we can date the rock. But if we have a rock of known age, then we can date the fossil. The problem, there is no absolute reference point. Unfortunately, these fossils or these rocks don't come with a date label. And the other thing is we can't take the rock, put them into a machine, close the door, press the button and beep, the age comes out. What they do is make measurements of certain substances in the rock or the fossil, depending on what you're trying to measure. And then from that, you apply your assumptions to arrive at a conclusion as to what you believe the age is based on the concentrations of these materials. So before we start talking about carbon dating, I'm sorry, but we have to do a little bit of a physics lesson. So I know for some of you looking there, the last physics lesson that you did was a few years ago. Okay, that's all I'm going to say. So the hydrogen atom is the simplest atom. If you look at the periodic table, and it's written this way, an H with two numbers. Why is it simple? Well, because the hydrogen atom contains one proton, and that's the number you will see down here. The proton in the nucleus of this atom has a positive charge. Around this nucleus, there's an electron that orbits, a bit like the moon orbits around the Earth. Well, this electron orbits around the nucleus, and the electron has a negative charge. So the overall charge for this atom is 0. It's neutral. It does not have a charge. So the positive balances out the negative. Okay, so this is the hydrogen atom, very simple atom. The carbon atom is a little bit more complicated. It has this number 6, which is what defines it as carbon. It has 6 protons in the nucleus. It has 6 electrons that orbit around the nucleus in 2 different orbits. 2 in one orbit, 4 in a different orbit. So far, the overall charge is neutral. But it also has some neutrons. It has 6 neutrons in its atom, in its nucleus. They do not have any charge. So you can see it's a much more complex atom than hydrogen. And this top number then, it's the sum of the protons and the neutrons. So in this case, it's 12. And it's the relative atomic mass. Protons plus neutrons. They ignore the weight of electrons because the weight of an electron is insignificant compared to the weight of a neutron or a proton. So this is the relative weight of one atom from another atom. All clear so far? Carbon-12 is the common form of carbon. It's very common element in on this earth, and it's essential for life. Every single form of life, plant or animal, contains carbon. Otherwise, life would not exist. Now, carbon-14 is a very rare version of carbon-12. It's called radiocarbon, or it's called an isotope. So it means it's a variation of the normal atom because it has 2 more neutrons than carbon-12. Carbon-14 is produced by cosmic rays which hit our outer atmosphere. And so these cosmic rays, they are energy. They hit our upper atmosphere. It creates these high-speed neutrons which fire in all directions. These neutrons go and hit the nitrogen in our atmosphere and transform the element from nitrogen into carbon. And this is called carbon-14. Now, currently, the equilibrium of carbon-12 to carbon-14 is there is 1 atom of carbon-14 to every 10 to the power of 12 atoms of carbon-12. So 1 atom of carbon-14 to 1,000 billion atoms of carbon-12. Very rare. Carbon-14 will behave exactly the same way as carbon-12. So it will combine with 2 atoms of oxygen and form radiocarbon dioxide in the atmosphere. This carbon dioxide is absorbed by the plants in the process of photosynthesis. And so these plants will absorb all the carbon dioxide that contains this carbon-14. The herbivores, like this sheep, eating the plant material, will absorb the carbon-14 as well. The carnivores, like this tiger, eating the herbivores, will also absorb the carbon-14 into its body. And so the plants, the sheep, the tiger will each have the same concentration of carbon-14 in its body compared to the atmosphere. It's called the equilibrium concentration. Now, when that tiger dies, it will stop absorbing additional carbon-14. The carbon-14 will start to decay, radioactively decay. And so if we measure how much carbon-14 is in the bones, it will give us an indication of when the tiger died. We can do the same thing with plants when they die. So carbon-12 is stable. Carbon-14 is very unstable, and it decays back into nitrogen. So what do I mean by being unstable? The atomic structure has got too much energy. It's like it's nervous. The atom's nervous. It wants to relax into a lower energy state, a more stable state. So it does so by releasing a beta particle. The process is carbon-14 to nitrogen, and we can predict the time it takes to do this. It's called the half-life. The half-life is 5,730 plus or minus 40 years. What does that mean? If I have a certain quantity of carbon-14 in 5,730 years, half of it will have converted to nitrogen. In the next 5,730 years, that half will again be halved, and so on, every 5,730 years. So we can plot that on this graph. So 100% of the carbon-14 over years will get less and less and less and go towards zero. Never reaching zero, but eventually, it gets very, very close to being no carbon-14. By measuring the ratio of carbon-14 to carbon-12 in the bone, in the plant, we can calculate or estimate when that animal died. So that poor tiger, over time, the carbon-14 decays, has less carbon-14 present in its bones. Now, there's a couple of very important pieces of information about how carbon-14 works. First one is it only works on once living organisms, plants or animals. Okay, if someone says, oh, this rock was dated with carbon-14, you said, hang on a minute, that doesn't work. The other very important piece of information is that carbon-14 only works if the plant or the animal died less than 50,000 years ago. There is a special technique called AMS that goes up to about 80,000, but that's really the limit. The reason for that is beyond 50,000 years, there is so little carbon-14 left that we can't really measure the quantity accurately. Not enough to trust the measurement. So two very important pieces of information here, which we'll come back to. Now, in the carbon-14 dating, it sounds like here we have a good method for measuring things that are not too old, just tens of thousands of years, according to the evolutionary thinking. But there are several factors that will influence that measurement. For example, the magnetic field. This is one of them. Well, we know that that magnetic field of the Earth, since we started measuring it, has decreased 30% in the last 100 plus years. The magnetic field of our planet acts as a shield against cosmic rays. The weaker the shield, the more the cosmic rays penetrate the atmosphere. And that's bad news for us because cosmic rays are harmful to our DNA and other things. So it means if we measure something that's old, when the magnetic field was stronger and we were producing less carbon-14 in the atmosphere, it will look older than it really is because the starting point was different to what it is now. But unless we were there to measure that concentration, we don't know for sure. We're assuming the concentration back in the past. And there are other things like nuclear testing. So if you were to take a plant that was affected or near a nuclear explosion where the energy actually generates a lot of carbon-14, you would find it to be artificially younger than it really is because there's more carbon-14 present. And also the vicinity to motorway, they took a living plant, had it dated by carbon-14, and it came back as tens or hundreds of thousands, not hundreds, but tens of thousands of years old. But the plant was still living. Why is that? Because cars burn fossil fuels. Fossil fuels are fairly old and have very little carbon-14. So the carbon monoxide being given off by the exhaust of the cars is very poor in carbon-14. So near the motorway, it looks artificially old because there's very little carbon-14. but not because it really is. It just looks old. Now, when we talk about dinosaurs, we think millions of years, yeah? At least it's always presented to us that way. Well, in 1990, Mary Schweitzer and scientists from Montana University found an almost complete specimen of Tyrannosaurus rex. Now, all our youth know about T-Rex from the Jurassic Park films, right? These mean, nasty dinosaurs. We wouldn't want to meet them in a dark alley. But what was so unique about the particular T-Rex that Mary Schweitzer, who is an evolutionary scientist, well, she wrote in her report, because they had to cut one of these, the femur of the T-Rex, to be able to transport it in the helicopter. She wrote in her report, some parts of the femur were not completely fossilized. Inside the blood vessels, they found small, round, red, translucent objects with a black center. Red blood cells. Now, red blood cells are made primarily of water. Water does not survive 65 million years. And the dinosaurs are considered to have gone extinct 65 million years ago. Inside the bone, in the marrow of the bone, there are blood vessels. It's a big bone. And these blood vessels were still flexible. You could squeeze out a thick, gooey liquid which contained these red blood cells. Now, in the marrow, they still contain the nucleus. Once they go from the marrow into the bloodstream, they no longer have the nucleus. There were other parts that were flexible, like elastic. You could pull it apart with your tweezers, stretch it, and it will come back again. This was weird from an evolution perspective, to find a dinosaur that wasn't fossilized. How could this be possible? There is only one explanation. It cannot be 65 million years old. So the evolution scientists, not her team, said, well, this is a fraud. Well, no, she was an evolution scientist, and as scientists, they have to be scrupulous in their scientific methods, because they knew they would come under criticism. And so some scientists said, okay, we need to find an explanation. Well, maybe the hemoglobin, the iron in the blood, preserved it. So trying to find explanations, just like the test with the dripping water, find explanations for why certain things happen when you think you know the answer. The only real explanation is this is not 65 million years old. In 2012, at the Western Pacific Geophysics Conference in Singapore, a team of scientists presented a paper where they had dated some dinosaur fossils by carbon-14. Now, what's so strange about that? Well, an evolutionist, putting on his glasses of millions of years of evolution, would never date a dinosaur fossil with carbon-14. Why? Because they know it's too old to be dated by carbon-14, and we would not find any carbon-14, and so we're wasting our money to paying a laboratory to measure something that we know does not contain carbon-14. But some scientists weren't limited by these starting assumptions, and they had it dated. And the dating of 8 different dinosaur specimens came back with dates varying between 22,000 and 39,000 years old. They weren't the only team. Lots of other scientists independently have dated dinosaurs and found carbon-14 in them. Now, what's interesting in this conference is that afterwards, after the conference, online, when they published the abstracts of the different papers, the abstract of this paper was missing. Because there were actually 2 presidents of this conference, they decided that it couldn't be possibly scientifically accurate to have dinosaurs with carbon-14. There must be a big mistake. And so they assumed it wasn't worth publishing it online. Our assumptions are powerful. it changes our behavior based on what we believe are the starting points. But what would we do if we want to date something that's older than what we think is 50,000 years old? How would we date the rocks then? Well, we can't use carbon-14, but we can use other radiometric dating methods on rocks, on igneous rocks, in other words, solidified lava. We cannot measure using these dating methods limestone or sandstone. So how do these techniques work? Well, we can have some elements that are radioactive and they transform, they change into other elements over time. So for example, in this example, I have rubidium-87. It's an isotope of rubidium, which over time decays into strontium-87. Now, if we measure the rate of decay and extrapolate it, we can estimate that the half-life of this process, unlike a carbon-14, which is 5,730 years, the half-life is measured in millions of years, okay? Extrapolating what we can measure. So we can accurately measure isotope concentrations. But isotope concentrations are not dates. They're just concentrations. So we have to interpret the concentrations to arrive at some conclusions as what we think the age of the rock is. There are some assumptions that are applied. Remember our experiment here of dripping? You assumed when you came in that I was honest, that you had the tap dripping constantly. You assumed that I wasn't trying to cheat you and started with an empty container. These are starting assumptions. And with the dating methods, they do exactly the same. What are some of these starting assumptions? One is they assume no daughter isotope is at the start. So let's say we find a rock today that we want to date. We can measure the parent element and the daughter element. So it decays from parent to daughter element. We can measure those two concentrations. When we measure that, assuming that when this lava solidified and the rock was formed, and let's go back, let's say 350 million years, we assume that there was only parent element and zero daughter element. Now, were they there to measure that? No. So do they know for sure that there was zero daughter? No. So is this a valid assumption? Can they say for certain that these were the starting conditions? The answer is no. But it's a fundamental starting assumption for their calculation. The other assumption is the system is closed or isolated. In other words, that no parent or daughter isotopes are either added or removed in those 350 million years. So that same rock, what we're saying that for 350 million years, it was hermetically sealed, isolated from the rest of the world. Now we know that rocks are permeous, especially at the beginning of their formation. In other words, water passes through them. And we know that water dissolves elements. And so we're saying that for 350 million years, nothing was added and nothing was removed because it's like that rock was sealed. Can the scientists say for sure that no elements were ever added or removed in 350 million years? No. Why? Because they weren't there to observe it for 350 million years. Another starting assumption is that decay rates are constant. Well, this could be considered maybe a valid assumption. So what we're saying is that for 350 million years, that same rock, the rate at which the parent element decayed into the daughter element was constant, stable. Until recently, that may have been considered a valid assumption. However, now we're not too sure. Carbon-14 half-life varies depending on how close the moon is to the Earth in its orbit. We haven't understood why. There's a project called the RATE project, RATE, the results of that project indicates that maybe even the decay rates for rocks isn't constant. So again, can we say for sure that the decay rate has been constant for 350 million years? No. Why? Because we weren't there to measure it for 350 million years. Remember our little experiment with testing the rock and the different ages and applying posterior reasoning to arrive at the right conclusion? Again, is this good science? We're applying too many assumptions. We're assuming we know pretty much the starting point. This isn't a robust scientific theory. In my professional experience, for many years, I worked for a company that made silicon wafers that are used for integrated circuits, microchips, your memories, your microprocessors, etc. So the end of our process was in a clean room. So we had suits and everything, filtered environment, everything controlled. We had to reduce the number of particles on our wafers when we put them into sealed boxes with bags, and then went to our customers like the Intels of this world. And they would open the boxes in clean rooms as well and process those wafers in specially controlled environments, because any particle would reduce the yield. These circuits would no longer work because they're so tiny. And we had to calibrate our wafers for particle. We had to measure each one before we could put it in the box and ship it to the customer. And we bought specially calibrated latex spheres from our suppliers, and they use special laser tools to calibrate them. And we had special laser tools that would scan the wafers and measure all the different particles of different sizes and we had to calibrate that on a regular basis to make sure that a machine was working correctly, that the laser wasn't deviating from the light intensity and everything. Now that is concrete science. That is good metrology. These dating methods don't work in the same way. So these are 4 fundamental assumptions that are applied to the dating methods. Are they valid? We have to question how valid they are. And I'll give an example. Lake Turkana in Kenya is renowned for many fossil finds of what are considered to be ancestors to man. And this particular photo is of a replica of a skull called KNM-ER1470, considered Homo rudolfensis or Homo habilis. And again, those who were here last night know that many scientists now, many paleontologists now, no longer accept Homo habilis as a valid taxon. So what's the history in this one? Well, there is this KBS tuft, this layer, which was dated by potassium argon. So that's potassium argon technique. It was originally dated as between 212 million and 230 million years old. But that date, once measured before, was considered too old relative to the fossils that they were finding there. So with this new fossils that they had found, they decided they had to redate the layer. So they took some feldspar and pumice and redated it as 2.6 million years old. And this date now was considered reliable, no longer the 200 million years old. This date was confirmed to be accurate by another dating method called paleomagnetism and fission trace methods. So everyone's happy now. But then Leakey, they were a husband-wife pair, found another fossil in 1972 called this KNM-ER1470. They found it under the KBS tuft. And therefore, being under, it should be older than the tuft. However, so if the tuft was 2.6 million years old, something under it would be about 3 million years old. And yet, the fossil looked much more recent. It was too evolved in its shape compared to what we were expecting to find. And so they said, we have to redate the layer. And so what they did is they took some other pieces of feldspar and pumice, and they redated them, and that date was confirmed by new measurements of paleomagnetism and fission trace methods by other scientists who came up with a new date of 1.82 million years old. Ah, that's good. That's exactly what we're expecting from the age of the fossil. And everyone now was happy again. Okay, so you see the difficulty really in using these dating methods, because we don't have an absolute measurement of the date. We have to interpret concentrations of isotopes. They don't come with labels, these artifacts. So the scientific dating is not so much a measurement technique, but a way of thinking. So why don't we test these methods? Let's do some good science here. Let's test them. So if we measure some rocks of known age, then we should get accurate results, yeah? So this picture is of Mount St. Helens in the US, which exploded in 1960. It erupted. Volcano erupted in 1960. They saw some lava flows. 1980. Yeah, sorry, 1980. They saw some lava flows from this eruption. The lava cooled down, solidified. And so they said, why don't we take some rocks that we saw with our eye? That's good science. We were there. We saw it. We know how old it is. Let's send these rocks for dating methods. So they did that and said, we don't know how old it is. Just measure it and tell us how old it is. The results came back and varied between 350,000 and 2.8 million years old. The rocks formed 20 years ago. A similar situation, potassium argon dating of 5 lava flows, 5 different lava flows of Mount Nguruau in New Zealand. The dates calculated from these 5 different measurements varied from 270,000 to 3.5 million years old. The lava flows observed by scientists were in 1949, 1954, and 1975. Again, gross inaccuracy in the measurement. Let's look at it in a different way. Why don't we try measuring the same rock using different methods? So again, the different methods should agree if we can trust them. So they took some basaltic rocks from Uinkaret Plateau in the Grand Canyon. It's one of the highest layers, some of the most recent rock layers. So they used 6 different measurements of potassium argon. They used 5 different rubidium strontium measurements. They used the rubidium strontium isochron, which is considered a more accurate dating method. And they used some lead isochron measurements of the same rock. The dates that came back varied from 10,000 to 2.6 billion years old for the same rock. Sometimes these measurements do give ages which agree with the observations, but many times there are major exceptions. They found some wood buried in tertiary basaltic rock in Australia. The wood dated by carbon-14 was 45,000 years old. The basaltic rock ran the wood 45 million years old by the potassium argon method. And the wood had obvious signs of being charred by the lava flow that engulfed it. Now, if anything, the wood should be older than the lava flow. And yet, a difference between 45,000 and 45 million years old. So remember, carbon-14 only works for something that died less than 50,000 years ago. After that, there isn't enough carbon-14 left to be able to measure it accurately, with the exception of the modern technique, which is called AMS, accelerated mass spectrometry, which allows you to go to 80,000 years ago. The youngest coal is considered to be millions of years old. Most coal is considered to be between 10 million or tens of million and hundreds of million years old. Every single sample of coal measured by carbon-14 contains carbon-14. What does that mean? It means the carbon or the plants or any animals that then became coal died less than 50,000 years ago. They took 8 Paleozoic diamonds from Brazil. The layer is considered to be hundreds of millions of years old. Now, the diamond is made up of carbon. Carbon could have had a plant or animal source. They dated some diamonds with carbon-14 using this special technique, the AMS technique, and they had dates that varied between 64,900 and 80,000 years old for the diamond. Now, remember, one of the assumptions is that when you measure these rocks, they need to be sealed, hermetically sealed, kind of, that you're not adding or removing. Now, what's better than diamond to prevent water going in and out? So what they did, they took a 9th diamond, they broke it up into little pieces, and they measured the little pieces. And the little pieces varied between 69,400 and 70,600 by carbon-14. Very uniform. What does this say? That the diamonds didn't take hundreds of millions of years to form. They formed in tens of thousands of years based on this measurement. They found a wood sample from Middle Triassic. The layer is known as Hawkesbury sandstone, which you can't measure with dating methods, but using the stratigraphic scale, they know that the layer is about 230 million years old. The wood in the layer, dated by carbon-14, 33,720 years. So quite clearly, the layer could not have formed all those millions of years ago. It formed after that tree died or that plant died. So can we trust the dating game? And we're coming to the end of the presentation now. Can we really trust it? Well, we've got to be very careful. Now, when you hear a new announcement, oh, we just found a new fossil of dinosaur, and this dinosaur is 63.526 million years old. Does it say in the fine print? And by the way, we applied these assumptions, and these are the error margins, and these are the likelihood of variation, etc. And these are the limits of no. It's presented like it's absolute fact, but it's not so clear because concentrations of isotopes have to be interpreted into ages. So I'm not saying they're useless, but we have to be more careful. We have to compare methods, use maybe historical counts if we have any historical counts for things that aren't that old, but we cannot say with absolute certainty the age. So just like last night on the topics we covered tonight, so the radiometric methods, the coal formation, the assumptions that we use in dating, the carbon-14 results on some objects that are thought to be old, but really are recent. And, the dating of diamonds, formation or rapid formation of canyons. If we compare the models to explain these things, we can see in many cases that the creation model has more weight than the evolution model. And like last night, these are some of the evidences, scientific evidences that I studied and decided if I want to remain true to the scientific method where I believe the evidence that science is telling me, then I had to change my position. I had to change my worldview, and I had to change my assumptions of the starting points, what the origin of life is on this planet. And I realized that the origin isn't evolution in millions of years, but I am here as a result of a creative event of a created God, because the model that explains that seems to make more sense to me in the light of science. So this is the end of my presentation. Are there any questions? And like I said last night, there are no stupid questions. So all questions are good.
Put up your hand.
Yeah, I've seen the guys make diamonds. It's a company they form, and you mentioned the yellow, pink, or any color. And they're really expensive because they manufacture them. So it's like they use these equipment, machinery with tons of pressure and heat.
Yes.
The material they use, varies. But my question is, if we say go into a cave or dig and we find diamonds, which is the hardest substance known, even harder than steel and so on. But how would you say, if somebody tells you these are formed millions of years ago, why do evolutionists still, knowing that you have these companies that make diamonds, they make them within 11 days, they said, something like that.
Weeks, few weeks.
Yeah. And why do they still, why don't they say, using their rationale, this, people looking on, not many people know that these guys are making diamonds, say, in weeks, which evolutionists and scientists are saying it's millions of years they form. And you just gave the evidence a while ago by your explanation. Why don't people realize that, this is not true, seeing that they can be made? You see what's happening in Spain with tons of water moving earth and stuff like that. Why do you think people still accept the facts, or the so-called facts of evolution?
Okay, good question. So these diamonds are made in factories all over the world now. They use these what called the reactors, but they do require a lot of pressure with the right conditions, etc. And even though you said they're expensive, they're nowhere near as expensive as the diamonds that they have to mine. So they're actually environmentally much more friendly than mining the real diamonds. They're not as big as the real diamonds. They're all real diamonds. They're not as big as the naturally formed diamonds, use the right terminology. So the question, why don't scientists then, if they know it's possible to make them, still believe it's millions of years? Because they will say, well, these are artificially created conditions. You don't see these artificially created conditions happening in nature naturally. So in nature, you need to rely on natural processes. Natural processes are the ones that we know about. So that's millions of years and heat and pressure, etc. So again, based on their normal thinking, they know that it doesn't happen in nature that quickly. But the reality is, we don't know what the conditions were like in the past. So as creationists, we believe that the flood created certain conditions on the planet that the evolution scientists aren't willing to consider. Those conditions created the right conditions to allow some of these processes to happen very fast, like the formation of coal, like the formation of diamonds. But again, it's all to do with assumptions. And yesterday there was a question as well as, well, if the evidence is so clear and I presented like it's so obvious that evolution doesn't work, a lot of people haven't considered these options. They're so brought up and so conditioned to believe in evolution that creation is just not even considered in the scientific sphere. And many scientists will accuse creationist scientists of not being real scientists. You'll find it. They're quite clear, come back when you do some real science. And they're very derogatory in their reference to creation scientists, said you cannot believe in creation and be a scientist. And that is, they're just so incredibly prejudiced based on their thinking, not because they're being nasty, but just they're so conditioned with thinking of this millions of years. And I can understand that. I was in their position. I did not consider that there were alternatives to evolution. So the majority of them are well-meaning. You know, they're not doing it deliberately, but they're just so conditioned by their thinking, and it's difficult to step out of this mindset. Any other questions?
I just wanted to ask, so evolution tries to answer the question as to how old is the earth, but I just wondered whether creation doesn't try to answer that, or have we? Because I think that's the question that people ask. Okay, we believe in creation, but what is the answer to that?
So
I know that God created there, but then do we have a number? I think that's what scientists are always asking, that how do we measure it?
Sorry, could you repeat the question? I didn't catch everything. Could you repeat the question?
So my question was, evolution, they will try to give you a number to answer the question as in how old is the earth?
Right.
Now with creation, we don't try to answer that, do we?
Okay.
And if we were to do that, my question is, because that's where the evolutionists will be asking us, so what is our answer? And if we were to have an answer, where do we start?
Okay.
And how do we go forward? That's the question.
Okay. So good question. And it's a question I often get is, in evolution, say the earth and life is millions of years old. The universe is billions of years old. What age do creationists present as the age of life, the universe? And creationists do present their thinking about the age, but it's not so clear-cut. So within what I can consider the pure creationists, there are two camps, two fields, two groups. There's one group of creationists that believe all of the universe and all known matter was created in that creation week. And it happened about 6.5 million years ago. Sorry, 6,500 years ago. Okay. Based on what? Based initially on the dating from the Bible, but looking at the genealogies. Because this person had was so-and-so old when they had the son, and then, died at age whatever. They had the son and died at age whatever. They had the son and died at whatever age. So we can recreate the genealogies. So then what science has done since then is to study the world around us. And they've seen that in many situations, what the evidences that we find seems to support these kind of ages. Okay. There's a second group of creation scientists who believe that life on this planet was created 6,500 years ago, roughly. It doesn't matter if it's 6.5 or 6,000 or 7,000. It's kind of thereabouts. But that the matter, the atoms that make up the Earth and the universe, could be a lot older. And I believe both are valid. Both are aligned and can be harmonized with the biblical account. There is scope in Genesis to look at both of those and to consider both of those. Now, I've done my own research, and I've looked at both positions, and I see valid points in favor of those that say life is recent, but the matter of the universe is older. And I see the points in favor of those that say all of the universe, everything was created recently. I tend to favor the first one, where life was created recently. There's no doubt in my mind. Again, that's my personal interpretation on my studies. But I believe that there is the possibility to consider that matter, the atoms, were created much earlier. Having said that, when we find these fossils in the geological layers, which evolutionists claim are millions of years old, even though the atoms that make up those rock layers may be old, the rocks actually formed after those animals died. Which means since the animals were created recently, thousands of years ago, the rocks could only have formed thousands of years ago. And I believe as a result of the flood, which created the conditions required for that fossilization that we see. And many of the geological layers and some quite weird fossil situations where we see entire herds of massive dinosaurs being buried and fossilized, jellyfish being fossilized, Ichthyosaurus giving birth to a live young and being fossilized. All these conditions, rapid catastrophic burials that only something like a flood, global flood, can really explain. And so I tend to favor that position rather than the other, but I've not taken 100% position because I don't think we have all the evidence to know exactly what the age of the universe is. Does that answer your question? Okay. Any other questions?
Okay. Mine maybe just a contribution. Well, the presentation you have given here is showing us that in science, when people come with new findings, especially in support of creation or doubting evolution, they hardly become published or made more available for. What we see is that, especially yesterday, you're talking about Lucy, and we saw that. And today, talking about even rocks which have been recently formed just 20 years, and they were dating millions of years.
Mm-hmm.
They tend to hide this information from the public.
Mm-hmm.
Like the presentation that was made, and they decided not to publish the one which was not supporting evolution. So my little advice to the young ones in particular, don't take anything absolute. Read wider to get extra information. That's what one of my professors told me. Don't believe any scientific finding unless you have proved it yourself, or you have read wide enough to make your own decisions. But some of us, the little ones, we just read, we go away. Look out for extra information and make informed decisions before we start walking around spreading falsehood.
Mm-hmm. Thank you for this comment. And I'd like to give an example of exactly this sort of thing. A few years back, they found this fossil. It was a nearly complete fossil. And what was unusual was that it was three-dimensionally fairly accurate. So many fossils are kind of flat. They've been squashed over time. So these layers form, they squash the creature. And so the fossil is kind of squashed. This one was very good three-dimensionally. It was a creature that was very similar to a lemur, these mammals that we know of now. But it was hailed as a missing link for the evolution of mammals, so part of our history. And it was touted as the 8th wonder of the world, this finding. And so there's big headlines about this, big fanfare that this either was this amazing missing link fossil that really helps support and explain our origins as humans and how mammals came to be. But then soon later, pretty much the whole scientific community concluded that actually it wasn't. And they called it Ida. This lemur was called Ida, this fossil. That really was just a lemur. And it now no longer supported the evolutionary lineage of mammals, and it kind of disappeared. There wasn't the big fanfare, we were wrong. No one likes to admit we're wrong. And so when these things then eventually seem like Piltdown Man was a hoax, we saw about, and we studied it yesterday, it kind of disappears and no fanfare is made of these mistakes. It's understandable. It's human nature. We don't like to admit our mistakes. But I think one of the things I really want to highlight is that scientists aren't 100% objective. We assume scientists are just absolutely, they look at the data and they just conclude, arrive interpretations and conclusions based exclusively on the evidence that they see. That is not the case. We are all influenced by our starting assumption. Creationist scientists and evolutionary scientists. We just need to try and be as open as possible to see what the evidence tells us. Okay. Any other questions? Back of the hall.
Thank you so much for all the information you've given us. I just want to address the fact that in the Bible, when we take the book of Genesis, when we take and add Matthew, I think we've been given enough information there that tells us of the genealogy of Christ Jesus, and we have the beginning. So when people are going all overboard looking for evidences, have we got literature? Somebody sitting down and putting these connections together to say, well, look, this is where we are coming from, and this is what we've been given. Has any scientist or creationist done that yet from your research that you've done?
Okay, so the biblical account, and there are two sets of genealogies. One of them is in Matthew, like you mentioned. Some would claim that there are gaps in the genealogy, but essentially, many creationists believe that it's complete enough to arrive at a conclusion, not the absolute age, but roughly about 6,500 years ago from the creation of the earth. And Bishop Ussher was the first one really to do this calculation. Although most recently we think it's a little bit different. He came within the precise date. But he was pretty much aligned with what recent creationists believe. So from a biblical perspective, from looking at the genealogies, it's difficult, although we can find evidence that supports the veracity of the Bible, the reliability of the Bible, and archaeological data, for example, is revealing evidences that support that the Bible is real. Like, for example, Sodom and Gomorrah. Historians would say never existed. It's just something that you find in the Bible. And then they found some tablets that referenced the cities of Sodom and Gomorrah. So we saw that they were real cities. The king Nebuchadnezzar, historians would say they never existed. He never existed, this king. Then they found tablets, and that referenced this Nebuchadnezzar. Okay, so there's archaeological evidence that supports the biblical position. But from a dating perspective, there are other scientific evidences that support this recent creation. Tomorrow night, I will share one of these. It's called mitochondrial Eve, that was actually found by evolutionary scientists, and that supports the creationist model and completely refutes the evolutionary model of hundreds of thousands of years of evolution of man. So there are scientific evidences of measurements and results that support a recent Earth, a young Earth. But when we build all these individual pieces of evidence and information together, it builds a stronger case that we can learn it's more reliable. And then from a spiritual perspective, from a Christian perspective, we don't just base our faith on the Bible on the scientific results. Yes, they can influence you. And in my case, the scientific evidence is what opened my mind up to the possibility that God exists. It didn't prove to me it existed, but it opened up possibility from each of us personally in our faith walk as Christians with God. We learned that he is reliable, that we can trust him in our lives. And that is the second part of evidence that we have each personally in our convictions, that we can trust what the Bible tells us.
Thank you again, Stefano. Beautiful presentation. If I might just add, scientists who believe in evolution, they have two problems. One is that if they accept that there is a God, then they have to submit to this God. And the second thing is that if they accept that there is a God who created things, then they lose millions of dollars in research money. And they do not want that. One of the research papers which came recently just to give you a taste of it, was what was the purpose of smile within the evolutionary process? Now, what was the purpose of people smiling when in these millions of years of evolution? Well, it's stupid to put a lot of money into studying such a topic. Well, the conclusion was that people started to smile to earn trust when they were going hunting. Now, it's silly, but people put a lot of money into it, and they earn a living. So that is what it is that we are facing in this world. But we are not confused. We know who we are, we know our identity, and we know that we have been created by a loving God. And with that, we will stop here. Again, please help yourself with the literature. And also, we have refreshments for all of you. So let us meet again tomorrow night. Tomorrow night is the last one, so make sure that you will be here. And then we will listen to the topic of tracing the origins of human diversity. May God bless you all. Let's bow our heads. Father God, we thank you for giving us so much information to be strongly grounded in the fact that you are an almighty creator, a God of love who wanted us to be on this earth. Dismiss us with a blessing, give us traveling mercies, and help us to be tomorrow evening again here to learn more about you. That's our prayer in your name. Amen.